we're going to start with Greg Schwab, Dr. Greg Schwab, and so we'll just let you get into your studies with the slides.
Okay, Kyle, we've worked with AGROTAIN for probably 5 years or so, and in general what we try to do is we try to test different fertilizer products and their ability to prevent nitrogen loss in extremely high loss conditions. And so all of the studies I'm going to talk about today, you have to keep in mind these are extreme loss conditions, and then we actually go try to apply them kind of in the worst possible time.
Did you purposely make those extreme loss conditions, or did you have to wait for those conditions to naturally happen?
It's interesting that you ask, yeah. So we rely on natural rainfall and natural conditions, and so what we do is we wait until the soil is wet and the weather forecast is for no rain in the at least next 5 days. And we're usually pretty good, but I always joke with farmers, if you want to guarantee that you don't have nitrogen loss from volatilization, invite me to do a study on your farm. So about maybe 40% of the time or so, you know, environmental conditions will be such that we don't have as much loss as what we hope.
You know, that isn't that much different than what farmers experience out there too.
Absolutely.
The unpredictability of the weather.
If you could predict the weather, you could save or make a lot of money, that's for sure.
Yeah. Well, let's get started.
So let's look at the first slide. So these are, like I said, they're all going to be no-till corn, high residue, high loss environments. And what we try to do is we try to compare urea that we know has volatilization loss problems to nitrogen sources that don't have the loss problem. And so in all of my slides you'll see something labeled AN, which is ammonium nitrate. And we know that ammonium nitrate is not subject to volatilization loss. And so that's kind of your no loss control comparison. And so in this particular study in eastern Kentucky, if we look, the urea untreated had a yield of 180, while the ammonium nitrate had a yield of about 215. And so you can see that this was a very high loss environment, and it's a good environment to compare other products. And so the next bar to the right, I'm sorry, go back to that slide. The next bar to the right is the AGROTAIN treatment, and it performs statistically the same as ammonium nitrate. The next slide is ESN, it's the Agrium product, and to be fair with this product, this was applied after planting. It's a slow release product, probably not the ideal application timing for this, and it didn't perform any differently than urea by itself. Next we have Nutrisphere nitrogen, which was right in the middle. So it statistically wasn't lower than AGROTAIN, but statistically it wasn't any higher than untreated urea. And then we have super urea there next, and it performed the same as AGROTAIN treated urea. And lastly we have ammonium nitrate that was dribbled on the soil surface. And so it's a good comparison to see what products perform well in this environment and which ones don't. Next slide, very similar study. This time AGROTAIN is on the left, and I'm sorry, ammonium nitrate is kind of in the middle there. Third bar versus urea on the far right, and again we see high loss conditions, and so we can compare the products. AGROTAIN on the far left, statistically no different than ammonium nitrate. ESN in this environment performed well, so it was no different than ammonium nitrate. And then we see Nutrisphere NSN, no different than urea. Super U, Nutrisphere with Super U, both of those were no different than ammonium nitrate. But when we mixed Nutrisphere with AGROTAIN, then we saw a loss in performance of the AGROTAIN. Next slide. I think this is the last slide we're going to show like this, but we have these ordered in highest yielding to lowest yielding, and so the control received no nitrogen. Ammonium nitrate out there on the left was the highest yielding at a little over 180 bushels per acre, and then you can just look down the line there and see which ones performed well and which ones didn't. By the time we get to the urea untreated, our yields are down around 150, so about a 30 bushel yield loss as a result of ammonia volatilization. Nutrisphere there again didn't perform any different than the untreated urea.
On the first two slides, I noticed you put about half as much nitrogen as we would normally expect for those kinds of yields. There obviously was other nitrogen somewhere in the system.
No, that's an important point. So another thing that we do to try to compare products is use a lower than recommended rate. And the reason why you do that is because then you're in the steep part of that response curve. And so being in that response, in that steep part of the curve, if you save nitrogen, then you see a big difference in yield. If we had put on a fully recommended rate, it might have been so much that we wouldn't have been able to easily separate those treatments.
You might mask some of the loss because you were putting on way more than you needed.
Right, exactly.
And let's face it, a lot of us, that's how we have handled the problem in the past, is by putting on more than enough in case there was a problem.
That's right.
That was when nitrogen was cheaper.
Exactly.
Yeah.
Now it's a little more expensive to try to go that route.